I kind of felt like the industry flatlined for a long time. Now, every company wants to print something or already is printing something and looking to print more. When people say I need full production capabilities, that means I need to make 1 million of these parts. The need for 1 million of anything is becoming less. With design cycles changing faster every year, you really have to kind of start weighing what is your max production, what are your target costs. I thought for 20-something years it was doing this. Right now, I say we're at the hockey stick moment where it's starting to really kick up.
All right, everyone, welcome back to another episode of DIB Innovators. Again, special live from the Space Tech Expo in Anaheim. Today, I've got Justin Smart, Additive Manufacturing Sales Executive at Impac Systems Engineering. Justin, thanks for joining me today. This will be fun.
Thanks for having me.
All right, so you've been in 3D manufacturing for a long time.
Correct.
Probably before it was a buzzword. Tell me how you got into it, and then what have you seen over that journey? You know, because it's been like 35 years, something like that, right? Tell me about that journey and how you've seen that change.
So I got into it because I worked in a prototype lab and they said, here's some new equipment that's cutting edge. See what you guys can do with it. So that was, I was like, we all thought we were wizards, because it felt kind of like wizardry. To be honest, I kind of felt like the industry kind of flatlined for a long time. Now, with better materials and I think driving the cost down of capital and the capital investment has just springboarded. Every company wants to print something or already is printing something and looking to print more. So that's the biggest change. I like to see the manufacturing coming back to the U.S. And so all my customers are making their parts here in the U.S.
So have the materials to print with changed more? Or talk to me about that change, and then the actual machines. Talk to me about how those have changed.
Okay. So specifically in photopolymers, the materials have become exponentially better. Exponentially. And in previous iterations, they were very sensitive. You couldn't even take parts outside because the sunlight would cause them to overly cure. Now there's real engineering grade plastics because companies like Loctite Hinkle, BASF, they're making real quality photopolymers. That's new within the last 5 years, I would say. That has really catapulted that specific technology. And then the other side, I think, is like, if you look at metal printing, is the cost to get into metal printing 5 years ago was 5 times more than what it is now. You used to have, it was recommended you have a metallurgist on staff to manage it. Now I see them being run by students. That's a big change, right? Because the workflow is so much easier.
All right, so tell me about Impac. Like, what do you guys do? How do you go about it? What's your competitive advantage? Share why you are coming out the market and how you're...
So Impac's been around for 40 years. So we're not some, fly-by-night operation. We've been around for a long time. Always been in...
This shirt would maybe say that.
Yeah, right. Like I said, wait to see tomorrow. Wait to see tomorrow's. But engineering-centric, used to sell software for engineering, like CAD programs, right? Got into additive probably 20 years ago. And what makes us strong is we've got a lot of tribal knowledge. Like I said, I've been doing it for 30 years. I understand the product, the technology. My 2 bosses have also got decades of experience with that. And then I got a full family of field service technicians from Texas to California. And those guys, my boots on the ground, they really kind of make the dream work for my customers, keeping their equipment running all the time, right? So that's our main strength, I would say.
Cool. Well, I know you brought something. Give me an example of what you guys...
Well, this is a product that we are have just brought to the United States. And so this product that you really can't see, it's inside of two 3D printed parts. So
what do you mean by that?
Well, everybody wants parts that are lighter and stronger. That's the name of the game. So this is an HP MJF printed part. This is a DMLS aluminum printed part. I took these 2 parts and put them together, and then I have a machine that we were able to inject what they call a toe of carbon fibers. It's basically a whole spool of carbon fibers all coalesced together with an epoxy resin and we force that through this tube and out the other side. And on this one, we did it 6 times. And then after the resin cures, we just cut it off and smooth. But you can see, show that to the camera, continuous carbon fiber going from my mounting point to my load point. And that's completely new for additive. There's no other machine that does it, that puts carbon fiber where you need it instead of where the machine can put it. And that's a big difference.
And for a non-additive manufacturing guy, what does that give you? Just incredible strength?
So this part right here was based off an original weldment part. We reduced the weight of the original.
What's a weldment part?
That's when you take a bunch of plates and weld them together. So imagine this piece, but it was like all box, like a plate here, 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 and they're all welded together. That's a weldment, right? And so you made the structure out of plate, basically. So this holds the same amount of weight as the original. It has the same vibration modulus as the original, and it weighs 78% less. So I'm doing all the work, removing 70. And so when this thing goes into space, I don't know what the exact numbers are. I've heard multiple numbers, but someone told me one time it's $10,000 like per ounce to put a satellite in space. I don't know if those numbers are as accurate, but
They're changing, but yeah.
I imagine it's quite expensive. So every ounce counts when you're putting it up in space. And so if you can reduce anything by 78% in weight, it's considerable. It's something you got to look at.
Hell yeah. And so who are your kind of customers then?
So for this particular product, we just brought it to the States. We're the only distributor in the United States for it.
So you brought it to the States.
So we went to Europe, to a show in Europe. We met some people that developed this process, and we said, we love this. We want to bring it to the United States.
Okay.
And so we got into a contractual obligation with them, and we are the distributor for the U.S. now for this product.
So you're not making this on your own, or you're doing it with their machine, or how does it work? So
we sell their equipment, just like anybody else. I don't make anything other than money, So, we sell, install, service, train for other OEMs, right? So HP,
okay.
One Click Metal, Big Rep, and there's several.
So you're selling the 3D printed machines, and do you sell the raw materials as well?
Yep.
Yep.
We sure do.
Okay. And so then your findings, manufacturing facilities or companies that want to create something.
Correct.
You'll train them how to make this potentially, or how to use it. Okay, that's cool. How much in the design process do you involve yourself in? Like, so let's say, company X wants to work with Lockheed, or they have some requirement. They want to apply this technology to it,
right?
They get kind of, here's what we need. How do you help? Do you help them make that jump of
Absolutely.
breaking that down?
That is probably the core of my job, right? It is. A lot of times my customers saying, we're making this part traditional manufacturing. We're CNC this thing. We've been doing it for 50 years. But we heard that this way is cheaper. And I will go through the steps to either tell them, yes, you're right, or no, you should keep doing it the way you're doing it, right? But oftentimes we find that it is more affordable to 3D printing.
And so how big are you guys? Where are you located?
We're located in Temple, Texas. It's about halfway between Dallas and Austin, a little town. Really good barbecue though. And, but I live in the Phoenix metro area, and I've been working, the Four Corner states, Nevada and California for about 10 years.
As you're teaching these companies, or you're working with these companies, where's I talk to a lot of other folks that are in the manufacturing, of like parts, vehicles, whatever it may be. Prototyping's one thing.
Mm-hmm.
Scaling is another. How do you see 3D manufacturing? Do you see that same gap? And 3D manufacturing seems to be really good at prototyping, but scaling production at like thousands of units seem like that's more of a challenge, or people walk into that problem because they bought their one machine to do that. Give me your kind of perspective on that dynamic.
I always say, one man's ceiling is another man's floor, right? So when people say I need full production capabilities, some people that means I need to make 1 million of these parts, right? If you need to make 1 million of any given plastic part, there's a chance that 3D printing may not be the best option for you. But especially with design cycles changing faster every year than it seems like in years past, the need for a million of anything is becoming less, right? So injection molding has got a lot of costs involved with it, with the tooling. And so we don't have any of those costs. So you really have to kind of start weighing what is your max production, what are your target costs. You got to get in there and do the math, really. So for instance, I know people that make certain products that if they made 2 or 3 a week, that's their full production. So it's a customer that makes some fairly customized O&P devices, right? That's their full production. Well, 2 or 3 in a week is not full production to most people, right? So it just depends on the product. But to scale, you do need a system that's kind of designed for scaling, right? And so that is another big change in additive where it's, some people just have the little FDM box. So how do you scale? Well, you just got to add 50 more or 100 more boxes. And some people do that, but you start hitting your head on changing filaments out. We run HP. That machine is designed for production. It's got a giant build area. It's got multiple build carts. It's made to run 24 hours a day, 7 days a week, if you have the need for that many parts.
So you are seeing the industry of these designing more for production. It's leaning that way. Because I mean, to me would be the biggest risk. Like you want to build drones, for example,
right?
And the shell of the actual drone body. DOW loves it. It's like, okay, now we need 10,000 of them. You're like, oh shit.
Right. Well, there's companies that are making 10,000 drones for the government on this printer right now today.
That's good.
Just south of here.
But they're doing it primarily with just multiple machines, like a bunch of machines.
Yep. But again, this machine right here, their main production system is quite large. So like this MJF system, the print area is 15 by 11 and a quarter by 15. So you can fit quite a few parts in there. Maybe not this one, but if they were small parts, I did a product for a customer. It was a small gear. I was able to get almost 13,000 of those gears in one build. And that would have taken me about 12 hours to print almost 13,000 parts. Now, they were small, right? But if you need 13,000 parts tomorrow, that's even with an injection molding machine, that can be difficult, especially if you don't have the tooling yet, right? So it's impossible at that point, actually. So
are you seeing the demand for your customers to take this like downrange or, forward deploy these capabilities for,
100%.
Whether it's in aircraft organizations deployed, the maintenance, and that may be different because you got to get different certifications, whether or not that's certified, but whatever that you are seeing that going down.
Yeah, there's a couple companies that I know of that are basically taking a Connex, a shipping container, and turning it into a deployable mini factory for drones. Okay, so it's got the printer inside, power source, all the things you need to make the drones, and that can be dropped anywhere in the world. Instant factory when it hits the ground.
So of all your customers, the folks you're working with, give me like 2 cool stories of what they're doing and how they're doing this. Like,
it's kind of corny, but I get the most pleasure out of helping people, So I have a lot of customers that are doing O&P devices. So I have...
What's an O&P device?
Orthotic or prosthetic. So an orthotic is something that improves, maybe you got a bad leg and it helps you walk, whereas a prosthetic is, I'm missing the leg, and it's a partial leg. So O&P devices and 3D printing go together probably better than anything I've ever seen, because every product is a little different because it's custom for that individual person. And in the past, all those devices were basically made out of leather and fabric and Velcro, and you just cinched it down until you couldn't take it anymore, and that was what they called a fit. Now we can scan your body and make a part that actually fits you perfectly, and it's not made for anybody but you. So I've got some people doing lower leg extremities, people that are missing digits, and so I love, and then cranial helmets for babies that have, misshapen heads, basically. It does sound corny, but it does.
Not at all.
It makes you feel good when you help an actual person live better.
I mean, there's a custom part for a person would be really neat. That makes their life better.
And we take all our 10 fingers and toes for granted. And, you know, if you're around somebody for about 10 minutes that doesn't have them, it's serious. Yeah, for sure. So that's my favorite. I love all my O&P customers just for that, because I know that I'm helping somebody out.
Yeah. How much of your work is space-based defense?
I try to treat all customers with the same, so it's always evolving, to be honest with you. Lately, the defense industry in my world is consuming almost all of my time. Yeah, it's
a big push right now.
a big push, not just for drones, but I have a lot of customers that make suppressors, and they can't make them fast enough because they're trying to help people from getting hearing damage, and so it's a good cause.
Absolutely. Metals versus plastics. Is that changing at all? When certain items are used or not?
Metal's becoming more accessible to the everyday man. Like I was saying earlier, how the cost of the equipment has come down, the complexity of the equipment has come down. I see a lot more metal printing at the university level because of its affordability and its ease of use. And so that's just kind of having a snowball effect, because now you got guys coming out of school that they've already have a lot of experience with metal 3D printing. Before, it was such a niche, expensive process that it just didn't get a lot of exposure for most people, right?
Talking about workforce. So as you're seeing these companies and you're training and working with them, manufacturing workforce has been a problem. Now you got AI, so now it's like maybe it's going to resurge in like excitement. The fear of the white collar job going away. But talk to me about like workforce. Are we doing better? Because it's been a struggle for a while. Have you seen, cities, areas actually making good changes where it would be cool to send your kid to, go be, someone working with 3D printing and manufacturing?
So the human resource problem has been the biggest problem since the dawn of time, right? I think it kind of ebbs and flows. I would say that, like, I don't know of any schools that have a 3D print course, but every school's got 3D printers. So if you're in any type of engineering school, you're going to get some exposure, just because there'll be one class they ask you to print a part or whatever. So that's awesome. So at least almost everybody coming out of school has gotten some exposure to it. Back in the day, probably 15 years ago, it was really bad. Nobody knew. You had to train everybody. That you had to pick somebody that was closest to these skill sets and then show them everything else, because nobody knew, right? But that's changed. It's definitely more common. I mean, what it is, half these kids have got that you see here, they'll have a 3D printer in their bedroom. Those kids are going to get old one day, and then so that wasn't happening when I was kind of coming up in the business, right? So that's going to be awesome. That's going to be a big difference. I would say, like, we hire a lot of interns every year at my company, and then, like, I just got a call the other day, like, hey, this one intern last year moved up to the Bay Area, and he's looking for a job in additive. So I've been reaching out to some of my customers, looking to see if they need anybody, right? Because people would prefer to hire somebody with experience in additive as they can, right? So I think that I promote that when I can to my customers. Hire an intern. Give them something to do over the summer.
Yeah, I love it.
And they're cheap.
They are cheap. Depends how cheap you are on how cheap they are. Great. So in theory, additive has, for a decade plus, it's going to change everything, right?
Yeah.
3D manufacturing, additive manufacturing. But what's changed? I mean, because it kind of was just still stalling.
Well, that's what I said. I thought for 20-something years it was doing this. Right now, I say we're at the hockey stick moment where it's starting to really kick
You're
off.
hitting that curve.
And it's for the things I already, stated.
Yeah, so 5 years. Tell me about, from now, the state of additive manufacturing industry.
Oh, wow. I don't even know. That's a philosophy, like you really got to think about that. I mean, because it changes so rapidly, it's like, 5 years ago, if I said you can get all kinds of cars and they're just going to drive you around. You might go, I don't think so, not in 5 years. But man, you'd be wrong, right? To have said that. So I think that the additive space is even more wild than that. As far as there's a lot of smart people trying really hard to come up with the next greatest, or not really next greatest thing, but to solve a problem, right? We're all trying to solve. That's what I do. I'm a problem solver, right? I mean, this guy that invented this, he invented this at his kitchen table, and was in grad school, and he worked on it for years until they finally got the process developed. So there's somewhere today, there's somebody at a kitchen table doing the same thing, right? We just don't know who it is.
Well, very cool. We're gonna have to wrap this up, but Justin, it's been super fun.
Awesome. It has been fun.
If folks want to talk, follow you guys or get, information on how they can acquire some of, the products you're selling, services, how would they do that?
Reach out to me, Justin Smart at impacsystems.com. Yeah, no T, Impac Systems. And that's about the best way to reach me.
Well, that's awesome. Super enjoyed it. Best of luck.